we will finish the presentation of CSEC Multiple Choice Practice Paper 4 with Part B, the final 15 problems. These problems will take us from number 46 to number 60. The first one. The diagram shows a regular hexagon inscribed in a circle, and we are required to determine the distance between X and Y along the arc. So we are required to tell the distance between, or to determine the distance between X and Y. Because of the geometric symmetry offered by the regular hexagon, the diagonals that go between opposite vertices divide it into 6 equal angles, each of 60 degrees. The angle that subtends the arc XY is equal to 2 of those angles, and is therefore equal to 120 degrees. So we are saying that the diagonals join in points that are opposite to each other. If we throw in those diagonals, then we will have 6 divisions of equal angles. The arc XY is subtended by 2 of those angles, each of 60 degrees. Therefore, the size of that angle is 120 degrees. And it is important for us to note that, and also to state that, we are talking about the diagonals that are opposite to each other, because we have a diagonal that may go from this point here to this one, or from X to Y. Those are called diagonals, irrespective of how close these points are together. They are also considered to be diagonals of that hexagon. So there we have the 120 degrees. The arc XY is a fraction of the circumference of a circle whose formula is given by, and we are talking about the formula for the circumference of the circle, and that is given by 2 pi r. The fraction is equal to the angle that subtends it. So we are talking about this arc being a fraction of the circumference of the circle, and we are attempting to determine the length of this arc by making use of the fact that it is a fraction of the circumference of the circle, and the circumference of the circle is given by 2 pi r. So the fraction that we are talking about will be the angle that subtends the arc, which is 120 degrees, and that is to be divided by the angle of an entire revolution. The angle of an entire revolution is actually 360 degrees. So the fraction is 120 over 360. That may be reduced. The fraction is equal to 1/3. We should be able to see that by the proportionate nature of the diagram, or by reducing the fraction. If we take a look at the diagram, we may see that if we take a look at the proportionate nature of the diagram, and we are able to do it at sight, we should be able to recognize this angle as being 1/3 of a revolution, and therefore the arc will be 1/3 of the entire circumference of the circle. That we may be able to do at sight. However, we may reduce this fraction in order to demonstrate that it is actually 1/3. And there is no difficulty in doing that. We may reduce by a common factor of 10 in which these zeros will be removed, and we know 12 into 12 is 1 and 12 into 36 is 3. So we have 1/3 right there. The fraction may be placed to the left of the expression. So instead of having this 1/3 here, we may place it on the other side. Of course, multiplication is commutative. Therefore, we should have no difficulty understanding that if we place the 1/3 to the left of the 2 pi r, then the answer will be the same. And that correct answer is option B. The options are taking into account the fact that formulae are sometimes hazy in the minds of the candidates. They sometimes do not remember where the 2 belongs. They do not remember if it should be in the power or the coefficient. And sometimes they do not remember if it is to be in both coefficient and power. This is sometimes the greatest downfall. So sometimes you have a formula that you need to apply. For example, in this particular one, this formula, the formula for the circumference of a circle, maybe a candidate will not be so clear, or the memory might not be so clear, and instead of writing 2 pi r, the candidate writes pi r squared. Or they may want to write 2 pi r squared. And that is a test of this problem, this particular problem, that you always remember your formulae and that you also remember them exactly. Here we have quite a few distractors placed here to cast a shadow in the minds of those candidates who are probably thinking that it may be pi r squared, it may be 2 pi r squared, and so on. But the correct answer is actually 2 pi r over 3, because this 1/3 is or may be placed in front of the expression, and we know that 2 multiplied by 1/3 is actually 2/3, and that is represented by option B. Jerry takes 16 minutes to drive to his workplace, which is 24 kilometers away from his home, and we are required to tell the speed at which Jerry traveled to his workplace. So Jerry takes 16 minutes to drive to his workplace, which is 24 kilometers away from his home, and we need to determine the speed. Speed is equal to distance divided by time. The distance is 24 kilometers. There we have it. Let us divide that distance by the time taken. The time taken is 16 minutes. The time is in minutes. However, the required speed is in kilometers per hour. To convert time from minutes to hours, we divide by 60. So 16 over 60, and that will represent the time in hours, because the speed is required to be in kilometer per hour. 24 may be written as a fraction, 24 over 1, and of course that is because of the way that the answer is presented with 2 separate fractions. Dividing by a fraction is equivalent to multiplying by its inverse. So multiply by the inverse right there. We have 24 over 1 multiplied by 60 over 16. The answer that we have there is the same as option D, only that the denominators are in different locations. So we have this is equal to this, The only difference is that we have 24 over 16 and 60 over 1, and that does not affect the value of the answer in any way. Of course, all we need to do is just switch them around. Each exterior angle of a regular polygon measures 45 degrees. How many sides has the polygon? The formula for the sum of the angles of a regular polygon is based on the interior angles. One may want to take the angle given and without serious consideration attempt to use the angle in the formula as it is. Fortunately, there is no regular polygon with each interior angle measuring 45 degrees. I think that the greatest initial problem that we may have is that we are thinking angles of a polygon. Then the angle that is given is one of the exterior angle. But because our formula makes use of the interior angle, all candidates might be thinking, or most candidates, or even few, I do not know what percentage, may be thinking immediately to use that angle as interior. And we are saying there, fortunately, there is no regular polygon with each interior angle measuring 45 degrees. The interior and exterior angles of a regular polygon are supplementary. They are to give 180 degrees. We may therefore find the size of each interior angle by doing what? Because they are to give 180 degrees, the interior and the exterior angle, we have the exterior angle. Therefore, we need to subtract that from 180 degrees, and the result will be the interior angle. Where n is the number of sides of a polygon, the total interior or internal angles is given by the formula. What formula? 180 multiplied by n minus 2. So all of the interior angles, if you add them of any polygon, you may use the formula 180 to be multiplied by n minus 2, and that will give you the sum of all of the interior angles. To arrive at an expression for each angle, we divide the total by the number of them. So if we want to find the size of each, we divide the total that the angles will add up to give, we'll divide that total by the number of angles. The number of angles is equal to n, so we will divide by n, and that will give us what? The size of each angle. And of course, take note of this word, regular polygon, because it is in a regular polygon that all of the sides and all of the angles are equal. Divide by n, we will get the size of each one of each interior angle. We already know that the size of each angle is 135 degrees. So the size of each internal angle is 135 degrees. We know, we have calculated it from right here. So this expression is equal to 135. The equation may be reduced by a common factor of 45, and we should be very quick to see when an equation may be divided throughout by a common factor, because that will simplify our working. So 45 into 180 is 4, and 45 into 135 is 3. Let us solve the equation on the next slide. So the equation will become that one. Expand the brackets and multiply the equation by n at the same time. We will have 3n on the right hand side, and n will be eliminated from the denominator on the left hand side. So we will multiply the entire equation by n, and we will eliminate n from this side, and we have 3n on the other side. Next, we will place the n's together on one side, and everything else that turns out to be negative 8 in this particular case will be transposed to the other side. So 4n, and this is transposed here, will be minus 3n. This negative 8 on transposition, we will have a positive 8 on the right hand side. Simplifying the left hand side, 4n minus 3n is equal to n. N is equal to 8. The correct answer is option C. 8 sides. Investigate what would have happened if we used 45 degrees as the size of each interior angle. Right. Remember that we were saying that some candidates might not pay too much attention to the fact that the problem said each exterior angle, and at the same time needs to be aware of the fact that the formula that we use for the total angles of a polygon, we are doing that in reference to the total interior angles. If that was missed by a candidate and the 45 was used instead of the 135, what would have been the result? The equation may be reduced by a common factor of 45 as usual. 45 into this is 4, 45 into that one is 1. So we will have to solve the equation as usual. We will expand. We have 4 times n is 4n. We have 4 times negative 2 is negative 8. And we eliminate the n by multiplying by n on the other side, and that is what we would have received. Then the n's will be taken together on one side, and we simplify this expression. Of course, we also transpose this negative 8, so we will have 4n minus n is equal to 8. So 3n is equal to 8. Finally, n is equal to 2 and 2/3, and that is what the candidate would have received. Now, what do we have here for the number of sides of a polygon, apart from the fact that this is not in the option? It couldn't have been. Well, it could have been, but we know that as an answer or a proposed answer for the number of sides of a polygon would have been disastrous. It is alarming that any polygon should have a number of sides that is less than 3, much more a fractional number. The polygon with the smallest number of sides is the triangle, and it has 3 of them. So the smallest number of sides that any polygon can have is 3, and that polygon is a triangle. And we do not imagine that we can have a fractional number of sides. If p minus 3 is the largest of 4 consecutive odd numbers, then the smallest one is what? Consecutive, that's the first thing that we are paying attention to. consecutive odd numbers. The first fact that is worthy of note in the problem is that the problem did not say consecutive numbers, but consecutive odd numbers. That is very, very important. Consecutive numbers differ by 1, but consecutive odd numbers will differ by 2. That is quite significant. Since odd and even numbers alternate, the difference between consecutive numbers is not 1, but 2. Another fact that is noteworthy is that p minus 3 is the largest. Since p minus 3 is the largest, the other numbers are smaller. Consecutive odd or consecutive even numbers always differ by 2. The next smaller odd number will be 2 less than p minus 3. So we are sure that p minus 3 is the largest. So we are going down. The one next in line will be smaller, and it will be 2 numbers away. So it will be 2 less than p minus 3. So from p minus 3 we will subtract 2. We may therefore subtract 2 from p minus 3 and continue to do so until we arrive at the smallest number. Fourth number is p minus 3. We need to subtract 2 from that one. So when we subtract 2, we have p minus 3 minus 2. We will have p minus 5, because we should not forget that when we are adding numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So if we add these two numbers together, they have the same sign, we add them, we have 5. But the answer will take the same sign as the numbers that we are adding. We will have a negative 5. So p minus 5. That is your third one. The second one, we subtract 2 again. We get p minus 7. And what do we know? Subtract 3, subtract 5, subtract 7. Notice that the number that we are subtracting is increasing by 2 each time. Following the trend, we may write down the smallest number as p minus 9. And the correct answer is option B. All of the other options represent good distractors, in that if we take a look at A, it is the result of subtracting 2 4 times. Although this would have resulted in 5 consecutive numbers, it is quite likely that a candidate could have made such a mistake. Right, so because we're talking about 4 consecutive numbers, some candidates may just subtract 2 4 times because of the presence of the number 4. C is the result obtained by adding 2 each time rather than subtracting 2 each time. It is not far-fetched that a candidate would choose this option. This one and option D would have been easily eliminated by a candidate who is quite aware that if p minus 3 is the largest, then p plus 3 and p plus 5 are impossible, since they are both larger than p minus 3. No number can be larger than the greatest one. So because p minus 3 is the largest, if you put in p plus 3, p plus 5, we do not imagine that that should really distract the alert candidate too much. It is not impossible for candidates to imagine that 4 consecutive odd numbers will imply that we need to add 4 times 2 to p minus 3. I would have preferred if one of the distractors suggested that some candidates would have ignored the fact consecutive odd and approached the problem with only consecutive in mind. The examiner could have chosen from among p minus 3, p minus 7, p, and p plus 1. Of course, we just have 4 distractors. Therefore, we do not imagine that all possible distractors could be placed among 4 options. But, in my opinion, if the examiner included distractors that implied that they would expect the candidates to use consecutive numbers, then I think that those distractors would have done as well. An article costs $161. If a profit of 13% is to be made when selling, the selling price in dollars is... This problem requires that we find the selling price or an expression for the selling price if a profit of 13% is to be made on an article that costs $161. Throughout the previous practice papers, this is what we are accustomed to. Increasing a number by a particular percentage, say 13%, is the same as adding that percentage to the original that represents what? 100%. The new price will represent 100 plus 13, which is equal to 113%. 113% is 113 divided by 100, and that will give us 1.13. Increasing a number by 13% is therefore the same as multiplying it by 1.13. So, increase by 13%, just put on 13% to the original of 100%. We get 113%, which is a number to be divided by 100. 113 divided by 100 is equal to 1.13. Increasing by 13% is the same as multiplying by 1.13. The requirements of this problem takes into account the identical circumstance to be treated in an identical way. The only exception is that the new percentage is not converted to a single percentage and it is not converted to a decimal fraction. Well, the principles are the same, but the treatment is different. So we will not go to decimal, and we will not have a single number as indicated by the forms that are in the options. The original is 100%. The new figure will be arrived at when we increase the original by 13%. This will take it to 100 plus 13, and that will be a percentage. So we have 100 plus 13, and that is the new percentage. Percentage is out of 100, so we will divide by 100. Each term in the numerator will be divided by the denominator. We have first 100 divided by 100, and that is equal to 1. And the other fraction, which is 13 to be divided by 100, and we do not have a common factor, so we will leave that one as it is. So it is 1 plus 13 over 100. That is the factor by which we will multiply the cost of the article of $161. That is the factor that the cost price will be multiplied by. The correct answer is option A. We could have kept the two percentages separate instead of combining them into one percentage. So 100% is 100 divided by 100, and 13% is 13 divided by 100, and those two we could have added them as two separate fractions, and 100 divided by 100 is equal to 1. That is reduced to 1, and of course 13 and 100 do not have common factors, and the fraction will remain as is. Furthermore, the forms in the options also attest to the fact that this is how the factor should remain. A company employs 12 gardeners at $26 per day and 8 clerks at $17 per day. What is the mean daily wage in dollars of the 20 employees? Mean. The mean daily wage may be found by dividing the total daily wage by the number of employees. Total divided by the number of them. The amount paid to the gardener may be found by multiplying the wage of each of them by the number of them. We need to find the entire or the total amount paid each day. We will therefore find the amount paid to all of the gardeners together and all of the clerks together, and add those two together. That will be the total amount, and that we will divide by the total number of employees, which we have here already as 20. We will therefore go straight ahead and find the amount to be paid to the gardeners in total. The amount paid to the gardeners may be found by multiplying the wage of each of them by the number of them. So the wage is 26, the number is 12. To that we will add the product of the number of clerks and the daily wage of each. We will multiply the number of clerks by the daily wage of each, and we will add that to what we have there for the gardeners, hence finding the total amount paid for the entire day. Let us now calculate the products. There we have 12 multiplied by 26 is 312, and 8 multiplied by 17 is 136. The sum is $448. This represents the total wages paid to the employees each day. The mean is equal to 448 divided by 12, which is the total wages for the day divided by the total number of employees. The mean is equal to $22.40 and that is represented by option C. Dividing by 20 is a simple process. For some candidate, it is automatic. However, we may make use of the simple principle. Division by a product is the same as successive division by each factor. Dividing by 20 is the same as dividing by 2, then dividing by 10. So we have 448 divided by 2. No problem doing this division because all of these numbers are even. So we just 2 into 4, 2 into 4, 2 into 8. That's not very difficult. Then 224 may be divided by 10. And that will give 22.4. And that represents a reduction by 1 place of decimal. That is how we divide by 10. Reduce by a place of decimal. A die was thrown and the scores recorded as shown, and we are required in this particular case to determine the median. The median is the middle item in a sorted list. When there is an even number of entries, the median is the average, of course the mean, of the two middle entries. The frequency tells us the number of each entry. In order to determine the total number of entries, we need to add the frequencies. We need to determine the total number of entries, and each frequency tells us the number of each score. So if we want to know the number of all of the scores, then we will add all of the frequencies, and we will add these numbers right here. The result will turn out to be 20. There are 20 entries. 20 is an even number. There will be two middle entries, of which the median will be the average or the mean of those two middle entries. Of course, when we have an even number of entries, we will always have two middle entries. 20 is an even number, so in this particular case, we will have also two middle entries. 20 divided by 2 is equal to 10, and that little bit of arithmetic is helping us to identify the middle entries. The middle entries will be the 10th and 11th entries. The median will be the mean of those two entries. So the middle entries will be the 10th and the 11th entries. The median will be the mean of those two entries. Remember that the median will be the mean of the 10th and 11th entries. We are now in search of the 10th and 11th entries. At the end of the first column, we would have passed the first two entries. So because the frequency is 2 here, we know there are 2 entries here, so we have passed the second entry there. How many entries there? There is only 1 entry in the next column. It will be the third. What do we know? In the next column, we have an additional 3 entries. At the end of it, we would have passed the 6th entry. With another 6 entries in the other column, the total number of entries will be 6 plus 6, which is equal to 12. The 10th and the 11th entries will be in that column and will therefore be both equal to 4. So if we add this 6, we have another 6 entries here. By the time we are through, we will end up at the 12th entry. Therefore, from the 7th to the 12th entry will be inside here, because at the end we will have the sixth entry at the end of this column. So entries 7 to 12 will be in this column. We have no doubt that the 10th and the 11th entry will be inside of this column, and they will be both equal to 4. The median will be equal to 4 plus 4 divided by 2, and the median is equal to 4. All candidates should be able to manipulate information in a frequency table in the event that the total number of entries is very large. For very large values of frequency, it might not be convenient to write each entry down in an examination. As indicated by the frequency row, some scores occur more than once. Let us use this fact along with the specific frequencies to write down all of the 20 scores. There are 2 ones. We have only 1 2. 3 3s. We have 6 4s. Also 5 5s. Finally, we have 3 6s. Let us now identify the 10th and 11th entries. There we have them, and they are both equal to 4. The median will be 4 plus 4 divided by 2. The median may be found by adding the 2 middle entries and dividing the result by 2. The median is 4 plus 4 divided by 2. That is equal to 4, as we calculated before. And we mentioned that we should be able to manipulate information inside of a table in the event that the frequencies are very large. So we know what would happen if the total frequencies turned out to be 250. I don't imagine that we'd want to put down every single digit. A die was thrown and the score recorded as shown. On this occasion, we need to determine the mean score. The mean is found by adding all of the entries and dividing the result by the number of entries. The first temptation is to look at the scores, find the sum of the values that are there, and divide the result by 6, like that. And the answer is 3.5. We have the scores 1, 2, 3, 4, 5, 6. We may just add them and divide by 6. Someone might be tempted to do that. Good for you that the answer is not among the options. Do not forget the fact that there are scores in the list that occur more than once. The number of times that those scores occur are determined by their frequencies. Our calculation must not be without taking that fact into account. As indicated by the frequency row, some scores occur more than once. Let us use this fact along with the specific frequencies to find the sum of all of them. There are 2 ones. Right. 2 times 1, 2 ones. we have 1, 2. 1 times 2, 1 multiplied by 2. We have 3 3s, 3 multiplied by 3. We have 6 4s, 6 multiplied by 4. 5 5s, 5 multiplied by 5. And we have 3 6s, 3 multiplied by 6. Let us now calculate the products. Those are the products. 2 1s, 2, 1, 2, 2, 3 3s, 9, 6 4, 24, 5 5s, 25, 3 6s, 18. The sum is 80. Let us find the mean by dividing the result by 20. So the mean is equal to 80 divided by 20, and 80 divided by 20 is equal to 4. So the mean is equal to 4. The diagram shows how a pupil spends the time between 8 a.m. and 8 p.m. on Saturdays. How many hours does he spend on TV from 8 a.m. to 8 p.m.? The time spent on TV is half of the total time. Well, it looks like half of the circle. If it does not, we should at least be able to identify that the angle associated with TV is the angle on a straight line. That angle is equal to 180 degrees. The total angle is 360 degrees. 180 is half of 360. So we are sure, if we cannot just look and tell that the time allocated to TV out of the total time is half, then we could go to the more specifics and consider that we have a straight line here for the angle that would represent TV. Angle on a straight line is 180 degrees, and that turns out to be half of the total of one revolution, which we know to be 360 degrees. The time spent on TV will therefore be half of the total time. The time from 8 a.m. to 8 p.m. is half of a day. Or we could just make the calculation. From 8 to 8 is 12 hours. But we may say that it is half of a day. With the number of hours in a day being 24, the time spent between 8 a.m. and 8 p.m. is 12 hours. So with the number of hours in a day being 24, the time spent between 8 a.m. and 8 p.m. is 12 hours. So the total time is 12 hours, and we need half of that for TV. 12 hours will be the total time accounted for in the pie chart. TV occupies half of that. A half of 12 is equal to 6. The correct answer is option D, 6 hours. AB is 12 centimeters, AC is 13 centimeters, and BC is 5 centimeters. What is the value of tan C? We have right here a right-angled triangle. Therefore, to determine the tangent of an angle is not far-fetched. According to the statement of the problem, the angle in question is at C. Right. To find any trig ratio of C, we need to name the sides relative to that angle which is at C. So we need to determine or give names, conventional names, to the sides relative to C. The hypotenuse is always the longest side, and it is opposite to the right angle. It really does not have anything to do with C. There we have the hypotenuse, opposite to the right angle. The side opposite to, facing, or on the other side of C is said to be opposite to C. So that is the opposite side to C. The side that is beside, alongside, or adjacent to C is said to be the adjacent of C. It is beside the angle C. Of course, we know that we have two sides that are adjacent to C, but the hypotenuse is the longest side, and it already has its special name. So the other one is called the adjacent. Tangent is opposite over adjacent. The opposite is 12, the adjacent is 5. The correct answer is option C. If we were sharp, we would have taken note of the fact that tangent is exclusive of the hypotenuse. Only the other two sides are applicable, and they are the 12 centimeters and the 5 centimeters. Only one option has 12 and 5 together. We could have chosen it without considering which is to be divided by which. So notice that the only option that has both opposite and adjacent is option C. It has to be the correct answer. Which of the following represents the equation of the graph? We have all of these expressions here. Which one actually represents the equation of this graph? When we solve an equation, for example, which equation? X minus a to be multiplied by all of x plus b is equal to 0. When we solve an equation like this, what happens? The sign of the constants in the factors will be different from those in the answer. So we have x is equal to a, or x is equal to negative b. So the signs in the answer will be different from the signs in the factor. The point where f of x crosses the x-axis are the solutions to the equation f of x is equal to 0 and are called the roots of f of x. We are talking about those points where this function is in contact with the x-axis. These points will be the solution to the equation f of x is equal to 0, and they are called roots of the equation. And the roots are negative 1 and 3. In this particular case, the roots of f of x are, no doubt, negative 1 and 3. A reconstruction, and we are saying reconstruction because we are imagining that these were arrived at from the solution of a particular equation. So a reconstruction of function requires that the sign of the constants will change in the factors of f of x. So when we are reconstructing the function, we are going to change these signs because we know that the signs that we have in the root will be different from the signs in the factors. So f of x is equal to x plus 1, of course. This will be plus, this will be minus because it is plus here. That is what we expect when we are changing from the factorized form to the solution, or vice versa. On the next slide, we will expand the brackets in order to arrive at a possible expression for f of x. All that is required is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. So let us expand. We have x multiplied by x is x squared. Then x multiplied by negative 3 is negative 3x, followed by 1 multiplied by x is plus x, and finish up with 1 multiplied by negative 3, and that gives us negative 3. Let us combine the like terms, if any, and there we have like terms. We will combine them. Negative 3x plus x is equal to negative 2x. The expression will be simplified to x squared minus 2x minus 3. We have arrived at our expression for f of x. Let us take it to the slide that contains the graph and the options in order to finish answering the question. X squared minus 2x minus 3, that is what we arrived at. But is that correct? Fortunately for some of us, that expression is not among the options. That might cause us to realize that the curve is umbrella shaped and therefore must have a negative x squared coefficient. This cannot possibly be a correct representation of this curve, because the curve has this particular shape that we call umbrella shaped, or some may say the curve that turns down, right? And that one must have an x squared coefficient that is negative, but this one is positive. What will we do? X squared minus 2x minus 3 is equal to 0 is a possible equation that we used in arriving at our expression. For the coefficient of x squared to be negative, this necessitates the multiplication of the entire equation by negative 1. This will cause all of the signs to be changed. So multiply this by negative 1, we get negative x squared. By negative 1 we get positive 2x. By negative 1 we get positive 3. Rearrange the terms in the expression, and we get 3 plus 2x minus x squared is equal to 0, and the correct answer is option C. On subsequent slides, we will take a look at why this is also a possible representation not of this curve, but any curve of this nature that has x-intercepts negative 1 and 3. The equation that we arrived at is based purely on the x-intercepts. It is for us to know that there are many possible curves of two main types. So for these intercepts, we may have quite a few different curves. We may have this one, the one that turns the other way, and other curves that the y or f of x intercepts may be different from this one. That will also be a determining factor in the equation of the curve. the U-shaped curves will have a positive x squared coefficient, and the umbrella-shaped curve will have a negative x squared coefficient. So that is broad. We have the possibility from just these two ordinates, -1 and 3, we have an infinite number of possible curves that have x squared coefficient being equal to a negative number, and an infinite number of curves whose x squared coefficients are positive. Multiplying the equation by -1 is by no means cheeky, because multiplying an equation by a particular number does not change it. And we can verify that by taking note of this particular equation. The solution of that equation is x is equal to 4. Then we may multiply that equation through by 5, and we get 10x is equal to 40. Its solution is still x is equal to 4. Furthermore, the y-intercept is positive 3. The constant in the equation has to be positive 3. This confirms our answer. The keen candidate will also realize that the curve, as it appears on the grid, is a bit faulty. The maximum point should actually be f of x is equal to 4, but the curve is a bit below that, and that we'll take a look at on a subsequent slide. We are saying that the f of x or y intercept is 3, and this y-intercept that is equal to 3 is a constant value in the expression. Therefore, if the y-intercept is positive 3, the constant value in the expression has to be positive 3. But in the one that we had first, it was not equal to positive 3, but a negative 3. Multiplying by a -1 in order to get the equation to be what we imagine that it has to be is by no means cheeky. As mentioned on a previous slide, the point where f of x crosses the x-axis are the solutions to the equation f of x is equal to 0, and are called the roots of f of x. So this problem that we are solving, determining the values of x for which f of x is equal to 0, as a matter of fact, was discussed before. All we need to do is recall. There we have them, -1 and positive 3. In this particular case, the roots of f of x are x is equal to -1 and x is equal to 3. The correct answer is option C. In all functions, no matter how complex, the value of the y-intercept, that is where the curve crosses the y-axis, is a constant value. That is why the constant value in the equation of the curve had to be positive 3, because the constant value is the y-intercept. The y-intercept is positive 3. Therefore, any equation that we are about to arrive at for this curve whose y-intercept is positive 3, the constant value in that expression has to be a positive 3. Also, notice that the value of x at the maximum point of f of x is x is equal to 1. If this is substituted into the equation, the result will be f of x is equal to 4. 3 plus 2x minus x squared, that is the one that we had before, that expression, and we will substitute x is equal to 1 into it. And what do we know? 3 plus 2 minus 1, and that is equal to 4. That is why it would not have been extraordinary for someone to determine that the curve is a bit off. Its maximum point is clearly below the value of f of x is equal to 4. So its maximum value should actually be 4, but we have it a little bit below 4, as we mentioned a little bit earlier. We did not mention that it should actually be at 4, but it is a little below 4, but we mentioned that the curve is a little bit off. In the parallelogram ABCD, AB is equal to 5 centimeters, BC is 4 centimeters, and the angle ABC is 56 degrees. What is the area of the parallelogram ABCD? In trigonometry, the area of a triangle is given by a half AB sine C, where A and B are any two sides, and C is the angle that those two sides form. Let us first insert angle ABC. That is the angle ABC. The middle letter is where the angle is located. The middle letter of the vertex, that is where the angle is located. Since a parallelogram may be divided into two triangles of equal areas, let us say that we are finding the area of one of those triangles. That one. We have two sides of that triangle and the angle that the two sides form. So for this triangle, we have this side, we have this side, and of course the angle that these two sides form is 56 degrees. So we have the two sides and the angle that those two sides form. Good. Area is equal to a half AB sine C. Substitute the sides and the angle. Substitute 5 and 4, and the angle is 56 degrees. And we get the area of that triangle is a half times 5 times 4 times sine of 56 degrees. The area of the parallelogram is twice the area of the triangle, because this triangle is just half of the parallelogram. So the area of the parallelogram is twice the area of the triangle. 2 times this area. Just this expression, and we multiply by 2. We will cancel half with 2. So 2 will cancel with the half, and 5 multiplied by 4 is 20. And the angle is 55 degrees. So these are gone. 5 multiplied by 4 is 20. So we have A is equal to 20 sine 56. The correct answer is option C. We could have used the fact that the area of a parallelogram is the product of any two sides times the sine of the angle that the two sides form, and that could have been done without using the triangle. So we could have used area is equal to 5 times 4 sine 56 for the area of the parallelogram without considering the area of a triangle. However, I'm attempting to make use of some knowledge that the candidate may have. Then we suggest this one, that the candidate will probably use on another occasion without having to go to the triangle. In the figure, O is the center of the circle, angle PQR is, and that is the angle that we are attempting to find, angle PQR, and we know that O is the center of the circle, and we have this angle 90 degrees. The principle that we will use to solve the problem is the angle at the center is twice the angle at the circumference. However, in order to ensure that the angle at the circumference is also inside of the circle, this necessitates the inclusion of the other angle at the center. So this angle at the center, if we consider the corresponding angle, which is the one outside, then the rule does not apply. So in order to determine the angle PQR, this one, we need to consider this angle. At the center, we have the angle of an entire revolution, which is 360 degrees. One portion is 90 degrees. The other one is the difference between the two. 360 minus 90 is equal to 270. So that is the angle. The angle PQR is subtending the same arc as the angle POR. So we have this arc right here, and this arc is subtended by this angle. Of course, we have two angles subtending that arc at that position. We have this one and we have that one. And also, this arc is subtended by PQR. We have the interior one and we have the exterior one. So the angle PQR is subtending the same arc as the angle POR, which is 270 degrees. The one at the center, which is POR, is twice the one at the circumference, which is PQR. PQR is therefore half of POR. The one at the center is twice the one at the circumference. So this one is 2 times this. This one is a half of this. A half of 270 is equal to 135 degrees. The correct answer is option C. When working with circle theorem, the rule that pertains to the angles at the center and circumference requires that both angles are inside of the circle. If 90 degrees were used, its corresponding angle would have been outside of the circle. Furthermore, it would have been reflexed and could not possibly be half of 90 degrees. So we are saying that if we are applying this particular rule, angle at the center is twice the angle at the circumference, both angles must be inside of the circle. If we chose this angle, its corresponding angle would have been outside, and the rule does not apply. Furthermore, if this is 90 degrees at the center, it could not possibly be twice the one at the circumference, because this one is a reflex angle. The point A is shown on the diagram. What are the coordinates of the image of the point A under a reflection in the y-axis? The y-axis is the mirror line in this particular case. The point is to be reflected in the y-axis. The line joining a point to its image must be perpendicular to the mirror line, and the point and its image must be equal distance from the mirror line. Since the mirror line is vertical, any line that is perpendicular to it must be horizontal. The point is 4 units to the right of the mirror line. Its image will therefore be 4 units to the left of the mirror line. We are saying because the line joining a point to its image must be perpendicular to the mirror line, and the point is already on this line, which is a horizontal line. This line is a vertical line, which is the mirror line. Therefore, we already have the line that is perpendicular to the mirror line. So this is the line that we need. Also, the object and its image are equal distance from the mirror line. Therefore, we have on this side 4 units. Then the image under the reflection in the mirror line of this particular point has to be 4 units on the other side. Good. The correct answer is actually option A. -4, 3. The line joining the point and its image will be horizontal. There will therefore be no change in the y ordinate, because we have original position of the point is right here, and the line that joins the point and its image is horizontal. Since it is horizontal, there is no vertical relocation, and because there is no vertical relocation, the y ordinate of the image must be the same as the y ordinate of the object. As a matter of fact, that fact could have been used in identifying the correct answer, because there is only one answer that has a +3 for the y ordinate. So instead of going through all of this problem could have been solved in a matter of seconds by knowing or by taking note of the fact that because the reflection is in the y-axis, the y ordinates of the object and the image will be the same, and the one that is the same as what we had on this side is 3. Therefore, it had to be the correct answer. That could have been determined in a matter of seconds.